Good day, everyone. I'm Rachel Sitap, and on behalf of my team, I'm delighted to present the Resume Analysis and Ranking System, an AI-powered recruiting system designed to make hiring more faster, smarter, and accurate. Today's recruiting process often relies on keyword-based filtering, which can overlook highly qualified candidates just because their resumes don't contain exact terms used in a job description. As hiring volumes continue to grow, recruiters need a more intelligent way to identify the right talent. To address this challenge, we developed RAP, a system that goes beyond traditional keyword matching by understanding the context and meaning of both job description and candidate preference. By combining semantic embedding, vector databases, hybrid search, and LLM-based ranking, our solution identifies the most relevant candidates with greater accuracy and efficiency. RAD is designed to help recruiters reduce manual effort into hiring decisions and discover best fit candidates through an intelligent end-to-end recruitment pipeline. Let's explore how each module contributes to building a smarter, faster, and more intelligent recruiting system.
Hello everyone, I am Ambulesh from Cornell University. Today we are presenting our project called RAP, Resume Analysis and KG. It is an AI-powered platform helps for HR to rank the candidates by the resume. In here, we take multiple type of inputs like JSON, JSONL, PDF, Word, Markdown language, etc. like that. We take this input and send it to the fast embedding system. It helps to collect the text from the data and send it to the vector. In this vector, we have a highly dimensional data structure of vectors like 3, 8, 5 dimensional vectors. In here, we use another one system. It's called BAAIG V2 as version 2. It helps to fetch the data from the image and multiple types of input. Helps to take the and work it as a text transformation engine. And it sent to the vectors by the pipelines to the quadrant system.
Hello everyone, I am Alan. I will now walk you through the quadrant storage, optimization, and benchmarking module of our AI recruiting system. In this module, we use Quadrant as our vector database to efficiently store resume embeddings along with important candidate metadata such as skills, experience, and profile details. This allows the system to quickly retrieve relevant candidate information whenever a recruiter submits a job description. To improve the overall performance, we optimize the storage layer by implementing payload indexing and efficient metadata organization. These optimizations reduce retrieval latency, improve query efficiency, and ensures the system can scale smoothly as the number of resume grows. To validate the effectiveness of these optimizations, we perform benchmarking by measuring key metrics such as retrieval speed, search latency, and overall system responsiveness. The result demonstrated that the optimized storage architecture consistently delivers fast, reliable, and scalable retrieval, making it suitable for real-world recruitment scenarios. The storage function plays an important role in enabling our hybrid search and ranking modules to retrieve and recommend the most relevant candidates effectively. Thank you.
Now, let's take a look at the hybrid search and retrieval model of our AI recruiting system. The objective of this module is to retrieve the most relevant candidates by combining semantic understanding with exact keyword matching. Instead of relying on a single search technique, our approach leverages the strengths of both to improve retrieval accuracy. When a recruiter submits a job description, it is first converted into semantic embeddings using fast embedding. These embeddings are then used to perform a vector search in Quadrant, enabling the system to identify candidates based on contextual similarity rather than just matching keywords. At the same time, a keyword search is performed to identify candidates with exact skills and technologies required for the role. The results from both searches are then merged, duplicate entries are removed, the scores are normalized, and a weighted ranking strategy combines semantic relevance with keyword relevance to produce the final ranked candidate list. By combining contextual understanding with precise skill matching, our hybrid search model significantly improves scriptural accuracy, and ensures recruiters receive the most relevant candidate recommendations. Thank you.
Nowadays, we successfully store all the vectors of the resume into Quadrant database and extract it using retrieval methods. But now the question is, among these clusters of vectors, which is the best one? Or let's say, what is the rank of each and every vector in the cluster? In order to solve this, we use an algorithm from the Beijing's Academy of Artificial Intelligence called as BGE algorithms. So let's get into the architecture. First, we just retrieve all the vectors is similar to the job description mentioned by HR. This has been done by BGE's small 1.5 billion parameter model. This model identifies the similarity score between the job description as well as the vectors in the database and retrieves only n number of vectors. Following that, in the second layer, we will rank each and every vectors based on a particular algorithm called as BGE's mini CPM algorithm. This mini CPM algorithm works based on cross encoders. Why not a bidirectional encoder, and why we are moving to cross encoders? Bidirectional encoders works on each and every data separately without identifying the relationship between each and every data. Whereas cross encoders have token level attention, that is, identifies the relationship between each and every input so that the relationship between each and every input is being identified and a rank is being given based on a particular relation or particular difference. Following that, a rank is being generated. We have a special layer called as cutoff layer. This cutoff layer works in such a way that it is similar to early stopping in deep learning's neural network training section, where if a particular resume is not up to the mark or not relevant to the job description, it completely remove it without processing it. This helps us to solve major issues like such as computational overload, latency issues, etc. So this is how we ranking algorithm has been solved. Thank you.